Huh? With your eyes. Yes, absolutely it is correct. But if you are in a dark room, there is a book on the table. Is it possible to see that book through your eyes? Why? Because there is no light. Today I am going to deal you with the topic light. Okay, today I am going to deal you with the topic light. Light is nothing but it is a form of energy. Light is a form of energy. Form of energy which enables us to see. Which enables us to see things. Yes, which enables us to see things. Yes, very good. So light is a form of energy which enables us to see things. Okay. Have you ever noticed the beam? Actually, have you ever noticed the beam of light coming from a car? That headlight car. It will be a ray. Yes, I'll give an example to you. Take a straight pipe. Okay, take a straight pipe as well as a lighted candle. Okay, you have to take a straight pipe as well as a lighted candle. You can see the lighted candle through the straight pipe. Whether it is possible to see the lighted candle through a straight pipe? Yes or no? Yes. Now you take a bended pipe as well as a lighted candle, and now you can see the lighted candle through a bended pipe. Is it possible to see the lighted candle through a bended pipe? Why? Rectilinear. Oh, yes, say direction. So from this we can say light travels in a very good. So second point we got from that is light travels in a straight line. Have you got it? Yes or no? Okay. So now you know very well, right? You have studied in your previous classes. Where do light comes from? Where do light comes from? Yes, sun sources. We have two types of sources. What are the two types of sources? Natural source as well as artificial source. You know what are the two types of objects also? You very well you know it is luminous as well as what? Luminous as well as non-luminous. What is luminous? An object which emits light. Non-luminous? Yes, very good. And now let's see about reflection. Okay, these are the basic things you know already. Yes, reflection. Let me take a mirror. Yes, see, when light falls on this polished surface, it will get reflected. So it will get reflected. When light polished on the highly polished surface, one side will be polished, the other side will be coated with a protective material. So when actually, where do this light comes from? Some source. So when light falls on this, it will get reflected. So this ray is called as incident ray. This ray is called as reflected ray. And what this line represents? It is a normal line. So the angle between this incident ray as well as this normal will be called as angle of incidence. The angle between normal as well as reflected ray will be called as angle of reflection. So from this we have two laws of reflection. The first law is angle of incidence will be equal to angle of reflection. Angle of incidence will be equal to angle of reflection. The second law, this is incident ray, this is reflected ray, and this normal, all lie in the same plane. So two laws we know already. The first law is angle of incidence will be equal to angle of reflection. Second law, reflected ray, then incident ray, and normal, all lie in the same plane. So these are the two laws. And now we have, in mirror we have two types. What are the two types of mirror? What are the main two types of mirror? Plain mirror, And one more. And plane mirror as well as spherical mirror. Now let's see about plane mirror. Okay, so in plane mirror, the reflecting surface will be plane. The reflecting surface will be plane. The mirror which we are using in our day-to-day life is a plane mirror. Yes. So here we are going to learn some characteristics of plane mirror. Okay. So first, see, let me take a plane mirror. See, we have two types of images. One is real image as well as virtual image. We have two types of images. One is real image as well as virtual image. Real image will be, actually it will meet at a point after reflection. Virtual image, whether it will meet or appear to meet. It will appear to meet after reflection. So we have two types of images. One is real image as well as virtual image. Real image is nothing but an image is formed. Actually, it will meet after reflection. Virtual image, it will appear to meet after reflection. And in real image, we will get the inverted. Actually, you know very well about inverted, no? If it lies below the principal axis, it will be called as inverted. If it lies above the principal axis, it is called as erect. So real means you will get inverted image. Virtual means you will get erect image. Okay. So let us see now. Let me take a plane mirror now. Actually, by using one reflected ray, we can't locate the image. We need two or more reflected ray. First, let me take one. Let me take an object. Let me take an object. See, what ray is this? Incident ray. What ray is this? Okay. By using one reflected ray, can we locate the image? No. We need one or two or more. Let me take one more incident ray, and it will get reflected. Whether we can, whether this line will be joined anywhere here. So what we have to do for that? We have to, yes, dot, and you'll get the virtual image. Yes. See now you can see here, you are getting okay. See, we are going to see the four characteristics of plane mirror. The first characteristics is you are getting the image behind the mirror or in front of the mirror. Behind the mirror. So it will be called as virtual or erect. Virtual. So the first characteristics is virtual. So erect in the sense it lies above the principal axis. So we can say it is erect. So we know very well the combination of virtual is erect, combination of real is inverted. And the second one, see, we have, okay, see, you listen, when you are standing in front of a plane mirror, okay, so if you are, see, give me one thing. See, now I am keeping this pen in front of a plane mirror. Whether the size of this pen will be exactly like this or it will differ. So we can say, what is the next characteristics we can say? Same size. So next characteristics is same size. And next is, see, usually mirror will be here and your object will be here. The distance between this mirror as well as this object will be 2 centimeter, means the image will be formed behind the mirror, right? So what will be the distance between that mirror as well as that image? It will be also 2 centimeter. So the object distance will be equal to, yes, object distance will be equal to okay, so we have some characteristics, virtual and erect, then same size, one more we have, right? Laterally inverted. What is the meaning of laterally inverted? Lateral in the sense? That is okay. What is the meaning for lateral? Side inversion. When we are raising the right hand, it will show us as a left. When we are showing left, it will show us as a right. So what is the next characteristics? Laterally inverted. Okay, so these are all the characteristics of plane mirror. Now let's go with spherical mirror. First, let us learn some terms in spherical mirror. Pole and the focus. Okay, so let us go with the image formation in concave mirror. So how many cases we have? Totally we have 6 cases. So this is the last case I am going to explain you now. See, this is a spherical concave mirror. So what is the other name for concave mirror? What is the other name for concave mirror? It is a converging mirror. Why it is called as converging mirror? Converges in the sense it will meet. It will meet rays after reflection. Now, see, this is a center point of the actually pole. Pole is nothing but this is a center point of the reflecting surface of a spherical mirror. What is this called? Principal axis. What is this called? Focus. And what is this called? Center of curvature. Now, I am going to explain you the last case. What is the last case? When an object is placed between focus and principal axis. So, I have placed the object here. Okay. So, when an object is placed between pole and focus. Okay, so we have 4 rules. What is the first rule? When a ray parallel to the principal axis, reflected ray will be passing through the principal focus. Second rule, when a ray passes through the principal focus, reflected ray will be parallel to the principal axis. Third rule, when a ray passes through the center of curvature, it will get reflected in the same path. Yes. So last rule we won't be applying here, but we can apply it. So any tool rule we can apply here. Let me apply the first rule. What is the first rule? When a ray parallel to the principal axis. So this is the incident ray. So this is the incident ray. This is the, what is this line called? It is called as principal axis. Now whether this ray and this ray is parallel, line is parallel? Yes. So when a ray parallel to the principal axis, what is the rule? When a ray parallel to the principal axis, it passes through the principal focus. Is it correct? So when a ray parallel to the principal axis, reflected ray will be? Yes. Now let me apply third rule. What is the third rule? When a ray passes through the center of curvature, it will be get reflected in the same path. Yes. Now when a ray passes through the center of curvature, it will get reflected in the same path. Whether this ray will meet anywhere here, it won't meet. So we have to extend at the back. So it meets here. See, so where we got the image now? Behind the mirror. Yes. So what is the position of the image? Position where an image is placed. Not virtual and erect. It is behind the mirror. So now we have to say what is the position. See where an object is placed between focus and pole. And where we got the image? Behind the mirror. Behind the mirror. Next is nature of image. Yes. How we are saying it is virtual and erect? See. Virtual in the sense we are getting the image behind. So virtual and erect in the sense we are getting the image above the this line is called as principal axis. We are getting the image above the principal axis, so we can say erect. So nature of the image is virtual and erect. Third one, size of the image.
Can you get the signs for 2B of extension as signs?
What's that?
Possible object. Sign and
That this one. Shall I stop and shall I?
for this case, write the signs of
Yes.
HL.
Okay. So size of the images. See, this is the size of an object. This is the size of the image. So it is enlarged. Okay. Now, see, we have some sign convention. You know the terms V, U, F, right? So V is nothing but it is an image distance. Image distance is nothing but distance from pole to the image. What is image distance? Distance from the pole to the image is called as image distance, and it will be denoted by V. And second, U is nothing but it is an object distance. This pole should be taken as object, so it will be 0. And here, what is object distance? Distance from pole to the object. Distance from pole to the object. F is nothing but it is a focal length. So focal length is distance between pole as well as focus. Distance from pole to focus. Image distance is distance from pole to image. It will be denoted by V. Object distance is distance from pole to object. It will be denoted by U. Focal length is distance from pole to focus. It will be denoted by small f. Now let us see the sign okay. Now for object distance. See, all the time we are placing the object on right side or left side?